Right, so this presentation is just going to run through the feedback for section C on the mock. So the first thing that I'll just point out is if you're not so confident with the underlying sort of theory behind the programming implementation of Dastan, is that there's a really good video on YouTube, which is about 20 minutes long, and it runs through the key aspects of how Dastan works. So I'd really recommend you watch that video, and the link for it is there. Secondly, in terms of practicing for section C and revising section C, I'd also recommend you look through the past paper questions for section C, which I'll have posted up alongside these videos. And although they're not specific to Dastan, they do give you a good idea of the kinds of questions they like to ask in this section. It will be the smallest section in the exam. In the mock, you probably did a slightly longer section than what would be expected. I think typically you can get around 15 marks for section C, whereas the version in your mock was about 24 marks in total. So there's a slight difference there. But yeah, well worth having a look through, because, you know, let's take, for example, this paper question here. You can see you've got a class diagram for whatever the particular skeleton program was for this exam. And obviously these ones you can't do without the code, but they give you an idea about the kind of question they might ask and how you'd know what an identifier for class was. Hopefully nice marks there. But then also, you know, a little bit more deeper questions about OOP and the theory of OOP in terms of class relationships. And you can see the question, we've got aggregation, composition, inheritance, 3 types. Which of these relationships is not shown in diagram 1? Well, that would, a little bit of revision here would rely on you remembering that the filled-in square diamond is a composition relationship. The arrowhead pointing to a class is a inheritance relationship, so 3 being the child of 2 in this instance. So, you know, in this one we can tick off composition, inheritance. It was aggregation, of course, that wasn't depicted in this particular section of a class diagram. There is a similar class diagram for Dastan, which I think you can see in the video, and it's worth just checking you're happy with the, well, there's 4 different types of relationship. So we've talked about inheritance and composition. Aggregation, of course, is the hollow diamond, and then you've also got just an association. So being able to explain what an aggregation or composition relationship is important. I think you'll find the definitions in the Quizlet if you're not sure, but remember it's about lifespans of classes and containing classes, and the diamond end of this notation always represents the containing class if it's aggregation or composition. Yeah, and then, I mean, other typical questions that you might get to kind of tab on. So, you know, things about exception handling and how it could be applied, the scope of local and global variables, how data is stored in binary versus text files. So, I mean, I'm not expecting that to come up, but they are the typical kind of questions that you might get. What is meant by a protected attribute? I think that was one of the questions that you've had on section C. So lots of definition-y type questions, and lots of questions where they'll say identify this particular feature in Dastan. So they're the things to look over and sort of have a practice with for section C. In terms of the actual mark scheme for the Dastan mock, let's just get to that now. So I think the first question was along the line of describing what this function does. And if you remember, when you're entering references to move pieces on the board in Dastan, you sort of apply a kind of a 2-digit integer effectively, don't you? And with this novel way they have of representing the board in Dastan, which is actually sort of like a single array or single list, you might say, rather than using a 2D array, you need a way of obviously being able to convert that 2-digit integer into an actual index, so you can update the piece at that particular position, and that's obviously what this particular function does. But in terms of the mark scheme for it, on these kind of questions, if you get asked to explain, the purpose of a function or a subroutine, is to really kind of talk it through sort of step by step. And so you'll see in the mark scheme here, it literally runs through and explains you know, the calculations that are done, and really specifically describes exactly what that subroutine does. The only thing that it doesn't indicate is that the actual return value is the index of a position within that 1D array on which the board is represented. But that's what I gave the marks for anyway. And I think the improvement point there is to really literally state out line by line what that routine is doing, if you get a question like that. Question 2 was about why a 2D array could have been used, and for that I was just looking in your answer to say that one dimension could be the row and the second dimension could be the column, so that was straightforward. And a lot of people got credit on this one. You know, the array was static, and so it uses a fixed amount of memory, and the board size is not going to change during the runtime of the game. So you know, that's why it was fine to use a 2D static data structure to represent the board potentially. So that's what I gave the mark for there, the fact the board doesn't change during the game. And then you've got metadata again. 99% of you gave the definition for 1 mark, so which was that metadata describes data in the file. So data that describes data, I gave credit for 1 mark, and then just any suitable example of data that you might want to include. So a lot of people said things like file size, board size, current scores, for instance, there. So yeah, that was a fairly straightforward one to mark. The next one was again a tricky question to kind of word the answer to, and again worth making sure you're happy with terminology, inheritance, polymorphism, you know, overriding, etc. They should all sort of mean something to you. But the mark scheme here for why it wasn't currently polymorphism was obviously a sort of a move option object is made based on the same class, but it just contains different data. That's not polymorphism. And I did give credit for answers, anything that mentioned the fact that there was no subclass involved and no child classes involved that were sort of overriding the move method and implementing the functionality, to give credit. But you know, a lot of people sort of struggled with that, but there was no inheritance used, there was no child class, so it was not possible for the polymorphic behavior to be kind of demonstrated. So that was the mark scheme for that question. Obviously in this one, they kind of show how it could potentially use an inheritance structure. It is worth pointing out that they could ask you to implement inheritance in the exam. So again, that's worth just checking you're happy with. You might remember we did the animals, reptiles and mammals program from last year, and it'd be worth digging that out and just checking you're happy with that, just in case maybe on one of the final questions, second to last question type thing, possibly they might ask you to do some inheritance and some overriding there. As to what aspect of Dastan, I have no idea, but you know, it is something that is possible. So yeah, so in terms of the mark scheme for this one, this would be polymorphism because we do have child classes. And the key thing they were looking to get across, I think, in terms of the understanding, is that these classes would still be treated as a move option, but they would be able to implement their own sort of behaviors where appropriate. So they, you know, they could inherit, you know, the methods and the attributes of move options, but they could implement have their own implementation for those methods if required. And yeah, that was kind of been looked for in the answer. I think it said something similar to that on the previous answer here, actually. So in order for it to be polymorphism, you need to have child classes being treated as their parent, which is not the case here because there is no parent-child relationship on the previous question. But here, you know, the child would be treated as a parent, but it could implement its own behavior. Okay, and then are there any questions? Straightforward. So, well, you know, why does parameter p is not a good variable name? Why should they have meaningful names? Yeah, anything that implied easier to understand, follow, you know, working with groups of programmers. Need to be specific here and just make it clear the purpose, to make the purpose of the variable clear. So sometimes I discounted a mark if that wasn't precise enough. But they were the 2 marks there. These questions come up a lot around so in fact, I've jumped down to D here, haven't I? So why is it important to have access modifiers such as private, protected, and public for both methods and attributes in OOP? So I was looking for that link to the encapsulation, got the first mark. So encapsulating sort of, we've mainly talked about it in the context of attributes, haven't we? So sort of keeping attributes private and methods public, and having a very controlled way. And a nice way of saying that is an interface, having a defined interface for how the values of those attributes can be interacted and modified with, as opposed to them just being publicly available to any class to be able to change in any which way you like. It's the way that you control access to those variables is done via an interface that you've defined in the class itself. So yeah, preventing that direct access got credit, exposing attributes to dangers from outside of the class. Okay, so it was that what I was looking for the marks there. These questions are very common though. What is meant by protected, public, and finally, I think private. And you've got to be precise here. And again, words from the mark scheme. In fact, I haven't got them on screen, so I'll just have to say them from memory. So protected attributes, the key thing that you're saying here is that the attributes are accessible to the class they're defined in and any subclass. So any subclass, so that's when you need protected, but no classes outside of that. Public methods are accessible to any outside class. And finally, private, the attributes are only accessible within the class in which they're defined. Okay, but the use of the word class is in the mark schemes and important. And maybe I've been a bit harsh there, but just it's about that precision. And if you check the mark scheme, if I just go back a couple of slides, remember protected attribute can be accessed within its class, and any derived or subclasses will get credit. So the word to use is class for those access modifiers, and nothing else really. Okay, and then the last question, again straightforward, difference between integer and floating point. Well, whole number was what I was looking for integer, and floating point returns a decimal with a decimal point, and then Boolean true or false, no problems there either. Right, and that completes section C feedback.